Hope you're doing great. Welcome to my channel, The Consistent Coder. So the problem today we are going to discuss about is threesome. I would highly recommend you to solve the two-sum problem on Leetcode first and then come to this problem. And if you want to have a solution for that problem, I have it on my YouTube channel already. So solve that problem first and then come to this problem. So the problem of threesome goes, given an integer array nums, return all the triplets nums at I, nums at j, nums at k such that I is not equal to j, I is not equal to k is not equal to j, and then sum of these numbers is actually equal to 0. And then we have to make sure that solution does not contain any duplicates. Okay, makes sense so far. Okay, what is he talking about? Given a bunch of numbers to us, and then we have to pick three numbers such that their indices do not match and the sum is actually equal to 0. So for example, I've taken -1, 0 and 1. What are the indices of it? 0, 1 and 2. And we know 0 is not equal to 1, 1 is not equal to 2 and 2 is not equal to 0. So all the indices are unique, not equal to one another. And then what is the sum of this? -1 plus 0 plus 1, it is equal to 0, which is why this is a solution to our in this case, which is why it is included in the output array. Makes sense? And then there is one more solution here, -1, 2, and then -1. So the indices of those are 0, 1, 2, 3, 0, 3, 4. And we know none of the indices 0, 3, 4 are equal to one another. So we'll calculate the sum. So -1, 2, and then -1. So that is also equal to 0. So which is why it is also included in the solution. Okay. And then what does he say? He says, notice the order of the output and the order of the triplets does not matter. See, here we talked about 0, -1, 2, -1, but he has given -1, -1, 2. So he's basically saying that the order of these triplets or the order of the arrays themselves, the triplets themselves, it does not matter. We can actually return them in any order. Okay, makes sense so far? Okay, what are the initial thoughts in order to solve this problem? Well, first of all, it is given that we have to select three random indices, right? So what is the initial thoughts? Well, brute force. So what will we do? We'll start a for loop that runs from the starting to the end, and then another for loop that runs after the index of this. So what I'm talking about, it looks like something like this, right? Okay, we have a first for loop which runs from I equal to 0, and then again another for loop which runs from j equal to I plus 1, and then one more for loop where k is running from j plus 1. Why I'm not running from j equal to I? Because we don't want to have any kind of duplicates, right? And also it is not satisfying the condition because I must not be equal to 0. If I start at j equal to I, they are actually equal. We don't want those. So this is some rough code, not exactly solution, right? Now if I sum these up and then if I get a 0, then that is my output, correct? But what is the time complexity of this? Since this is a nested 3 for loops, the time complexity will be O of n cube. And if we look at the time constraints of the given problem, given the nums dot length is actually 3000. So we're talking about 10 to the power of 3 to the whole power of 3, which is 10 power 9, which is very bad. So we cannot actually proceed with that solution, but that is a beginning step. So what can we do from now on in order to improve our time complexity a little bit? Okay, look at this condition once again. It says, if I sum three numbers that I take from my array, it must be equal to 0. Okay, what if I have all of them as positive? Think about it. Can the sum of those any three triplets from the array which I say all the numbers are positive, can there be any triplet where the sum will be equal to 0? No, because I know each and every number is greater than 0. The sum of any three numbers will always be greater than 0. 1, 2, 3, 4 something. If I take any three numbers from this, since I know each and every one of them is greater than 0, the sum cannot be 0. So I can actually, what do I need to do? I just need to return an empty list because it's not possible. But how can I use this point in my particular input? What I'm talking about is, how do I use the fact that if I have a bunch of positive numbers, I don't need to even look at them. I just know that the solution is not possible. So how do I group the positive numbers together? Because I need to know that if I come to a positive number, I need to know all the numbers to the right of it are also positive. Only then I can actually, break my for loop or something, right? So for example, if I have something like -1 and then -1, 0, 1, and then 2, right? If I sort these up, if my for loop if my I, num set I, if it is equal to a positive number, I don't need to look at anything that comes after it, because doesn't matter what it is, right? The sum of the three numbers can never be equal to 0. Maybe we have actually improved a little bit, but not much, because even here if you look at it, we are actually at the end by the time we came to the positive numbers. So in a big large array like 2000 3000 size, it is not going to matter that much, right? Even if we like eliminate all the positive numbers, but maybe we could use the fact that we have sorted it and then come up with a solution better than that. Okay, let's take this sorted array to the Google Canvas here. Okay, yeah. So here I'll start from here. We understood that sorting actually helps us to reduce a few cases, but not much. But how can we, improve it, by more much? Okay. So here we have, we are starting at this point. Now the number here at this point is -4, right? Now what if I have two numbers to the right side of it? In all these numbers, I have taken two numbers, and then I'll say the sum of those numbers is actually equal to 4. Okay, interesting. Okay, now I have -4 from here, and then I have 4 from here. That sum up to 0. That means I have found a triplet, right? Because what I'm saying is I have one number which is equal to -4, and then in another two numbers other than this number such that they sum up to 4. That means I have found three numbers which is actually equal to 0. That means I have found a solution, right? But what did I do in the process of finding this solution? I basically am saying that I have to pick two numbers from an array such that their sum is actually equal to some target. In this case, it's 4. So does this problem sound similar to any other problem that we have solved before? Yes, to sum. So basically we are looking for two integers such that their sum is actually equal to a target. Okay. But what is the best way to find those two numbers, what those two numbers are? We could actually use the fact that this is sorted, and then we could actually use it to our in a best way to come up with a optimal solution, right? I'll actually give you an example as to what I'm talking about here. Let's say for example I have 1 2 4 and then 6 and then 9. Okay, so these are the 5 numbers that I have, and then okay, let me mark it up as an array. Sorry for my bad drawing here. Okay, so the indices are 0 1 2 3 and then 4, and then I'll say my target is 15. All right, my target is 15. Okay, now what am I trying to find out? I'm trying to find out two numbers such that they add up to 15. And remember, this is a sorted array, right? Now what I'll do is I'll have 2 pointers, I, one that is starting from the beginning of the array, and j, another pointer that is starting from the end of the array. Okay, what do I, why am I doing this? Just wait for a minute, you will see why. Okay, now what I'll do is I'll sum up the first number and the last number. I mean the numbers that are at the indices I and then j. Okay, now 1 plus 9. What is 1 plus 9? Which is 10. Okay, is my 10 greater than 15 or less than 15? 10 is obviously less than 15. Okay, then what does it mean? That means I need to increase my sum that I've got from here, right? I have to increase my sum in order to make it equal to 15. How can I increase my sum? Can I increase my j? No. Why? Because I'm already at the end of the array. There is no other elements to the right side of it such that I can actually increase my j. But can I increase my I? Yeah, I can. And do I know that if I increase my I, my sum will be increasing? Yes. Why? Because the numbers are in sorted array. If I move towards the right, I am bound to find a number that is greater than the number that I'm currently using. Makes sense? So here what will I have? I'll increase my I to here. Okay, now instead of the sum 10, what will I have? I'll have 2 plus 9, which is 11, which I know is again less than 15. 11 is less than 15, but then again I know I cannot increase my j because I'm already at the end of the array. Okay, and now I can increase my I again here. So I have 4 plus 9, which is 13, which is again less than 15. So I'll again increase my I. Okay, now I have 6 plus 9, which is 15, which is exactly equal to the target that I want. So I know that this is a solution to my problem here. right? So I hope you understand why the sorted array and the two pointed solution is working for our case in order to make it equal to a particular target. So you understood this trick? Okay, let's put this particular kind of how we solved into this problem in order to solve it optimally. Okay. Okay, all right. Okay, so here we have -4, right? And then what do I need to have my target as in order to be able to find those two numbers? What do I need to have in this particular array such that the two number sum is equal to what? 4. Why? Because I have -4, right? And then what number should I have here such that if I add these two numbers up, I'll have 0. This will obviously be negative of this number, negative of -4. So only then I'll be able to add these numbers and get a sum 0, right? So I need to have a sum that is equal to 4. Now again I start from here, and then what do I have? I have -1, -1, and then 0, and then 1, and then 2. Okay, I'll start my I here and I'll start my j here. What is I plus j? 2 minus 1, 1. Is 1 less than 4? Yes, it is. So I'll increase my I. But I is something that I've already seen before. It doesn't matter. I don't need to process this element. Just think about it. If my I is fixed, I is already -4. I'm not changing it. And in this particular iteration, correct? And then j was actually -1. Okay. Which I have already, I'm trying to, call in this particular array. Maybe I think it is better for me to name it as j and then k in order to avoid confusion. Okay, let me actually name this as j and k. Okay. Okay. All right. So this is j and this is k. And now I is equal to -4. And then I'm trying to find two numbers such that the sum is actually equal to 4. So -1 plus 2 is 1, which is less than 4. So I'll move my j. And then I'm saying that I have my I as -4. And then I have already processed an element where the number was -1. Do I need to process it again? No, because I've already just processed it. So I don't need to process it again. So again, I'll have my j as 0. Okay, 0 plus 2 is what? 0 plus 2 is 2. And then 2 is still less than target. I'll keep on increasing my j. Okay, and then 1 plus 2, which is 3. 3 is less than 4. So I don't need to increase it anymore further, because if I increase it, j and k will actually be equal, which we do not want. So I cannot increase any further, and also I did not find any solution. That means I cannot find a solution with -4 as num set I. Okay, I have noted that, and then I'll move forward. Okay, I'll explore the next solution, and what will I do? I'll actually move my I pointer from here to here. So my I is here. Okay, if my I is here, my j will be what? -1, 0, 1, and 2. Okay, so here is my j, here is my k, and I is what? -1. So what should be the two number sum in order for me to have a total sum of 0? 1, because -1, if I find 1 in the right side of -1, I'll have the total sum to be 0, right? Makes sense? Okay. So -1 plus 2. What is -1 plus 2? It's 1. Is 1 equal to 1? Because that is the target that we are trying to find, right? This is the target on the right side that we are interested in. Yes, it is actually equal to 1. So that means I have found a solution where my sum is actually equal to 0. So now I'll just put it in my final result. Okay. And now what I need to do is I need to increase my j. But think about it. Do I need to increase my j only, and do I need to decrease my k as well? Because I have already explored the solution of num set k equal to 2. I don't need to actually put my k here, because I've already processed it. So I need to move my k back as well, right? Makes sense? Why? Because if I put my k as 2, and if suppose there was another duplicate for j, say for example I have I'm talking about -1, this is the I, and then k is 2, and then j I moved forward, but k I did not move forward. So j -1, and since this is a sorted array, it is possible for me to have -1 -1, right? So if suppose I did not move my k, what will there be another j such that the sum of these two numbers will again be equal to 1, so that the total sum will be 0? Yes, because I processed this particular j element. and this from element I have moved forward. Okay, makes sense. And I have not moved my k backward. And now what is happening? -1, and then 2. Again I'm getting 0, but I have already got the solution, right? -1, and 2. I have already got that solution. I don't want any duplicates, which is why I need to move my k back as well. Now what am I getting? I'm getting -1 and then 0 and then 1, right? And this is a solution that I have not seen before, and this is also a solution. So what I need to do, I need to increase my k and then decrease my k. Increase my j and then sorry, increase my j and then decrease my k. Okay, now I can't anymore do this because my j is no longer less than k, which makes no sense to move forward. Okay, so these are the two solutions that I have. Okay, -1, 0, 1, and then -1, 2. Okay, let's see the solution. What is it? -1, 0, 1, and then -1, 2. Make sense? Okay, let's quickly code it up. So what is the first thing that we want to do? We want to do is sort nums.sort, and then we want to sort it in the increasing order. Okay, a minus b, and then what do I want to do? For let we want to loop through it, correct? Okay, and then what we want to do is what will be my target? We'll take target is negative of num set I. Why? Because if num set I by this time you must understand what is the target. And now I'll have 2 pointers. Let j is equal to what? I plus 1. Why? Because obviously I cannot be equal to j. And then let k, we'll start it at the end, nums.length -1, and then while my j is less than k, and then what are the 3 different cases we might have? Num set I plus num set j plus num set k, it is equal to the target. In this case, let us have a variable where we store our results, right? So let us have that, let result is equal to something. And then what does it mean? That means I have found my solution. In this case, I'll do nums.push, num set I, num set j, and then num set k. Okay, what if my num set j plus num set k is actually less than target? What do I need to do in this case? In this case, I just need to increase my j pointer, right? And what if what is the other case? The other case is that my num set j and num set k will actually be greater than target. In that case, I need to decrease my k. Okay, makes sense. All right, so now what do I need to do? I just need to make sure that I avoid the duplicates. So when I found the solution, what do I need to do? I need to increase my pointer and I decrease my j pointer. So here what I'll do is while my num set j is equal to num set j minus 1, I'll just increase my j pointer. Why? Because think about it, if I have my j here and I found a solution and I'll move forward, right? If again here I find -1, I don't need to actually see the solution for this. I just need to move forward to the next one. Make sense? And then similarly, while num set k is equal to num set k plus 1. Why? For k we are moving backwards, right? So the next element for k will be k plus 1. So I'll decrease my k. Okay, and then here we have to make sure that we go on to the next iteration of the while loop. Why? Because if the sum is actually less than target and then I'm increasing my j, that means I did not found a solution. If I did not find a solution, I don't want to go in here and then unnecessarily move forward without actually getting a solution, right? So I'll do a continue here. Okay, let me run this. Okay, I need to return my result, right? Obviously, I did not return my result. Let me close this and then I'll return my result. Okay, yeah, there's one more case that I need to take care of. So for example, if my num set I is actually equal to num set I minus 1, that means for I also we have to take care. We have taken care of j and k, that is fine, but for I also there are duplicates, right? So even in this case also we don't need to do anything and then we'll continue. But here we have to make sure that we are I is greater than 0. Yeah, now it should work. Okay, it works. And then let me test this case as well. And then let's see. Yeah, as we see, the solution is accepted. Yeah, that's it for the video, guys. If you like the video, please do like, comment, and if you want to share, that is fine as well. I'll be uploading videos on a weekly basis, so if you want to get any updates, please do consider subscribing. And yeah, bye. Stay consistent.